Hi, this is Kelvin again. We're going to be starting part 3 of reviewing the book The Story of Science by Joy Hakim. Today we're going to talk about Pythagoras. So here we are looking at the 7 continents, and today we're going to be talking about a place in Europe. Let's focus on this red box. At the bottom of the box, you'll see the northernmost region of Africa. It's on the left-hand side. The bottom right is Asia. Everything else in white is Europe, and that's what we're going to be focusing on. He lived on an island just off the east coast of Greece called the island of Samos, and as you can see, Samos is to the west of Malta's Turkey. If you tuned in to watch our part 2 video of the story of science, you'll know that Thales was from Malta's Turkey. I just want you to realize that all of these events are happening in the same region of the world. Pythagoras was an odd man. He couldn't accept any chaos of any kind, which is the exact opposite of me. He wanted the world to be in perfect order. There's absolutely no way I could survive like that. He even liked order when it came to numbers. He liked numbers like 3 and 4. He thought that they were in harmony with the universe. He even liked decimals like 3.2, 3.33333, and 3.5. These are fractions. They have a beginning and an end. And if not, they have an order that they repeat, like 0.3333333333333333333, and so on and so on. I could do this all day. 33333333333. Those numbers made sense to him. They were rational. In fact, they're called rational numbers. What Pythagoras had a problem with were the in-betweens. There would be at least one number that would be chaotic. For example, in between the numbers 3 and 3.2, there's chaos. They're both rational numbers, and in between them, you have 3.1415926535889, and that's pi. It goes on and on and on forever. There are no repeating segments. This number was crazy to Pythagoras. These numbers were irrationals, and Pythagoras didn't want anybody outside of their group to know what irrational numbers were. Between every set of rational numbers, there's at least one irrational number. The people in Samos did not like Pythagoras, so they booted him out, and Pythagoras and his followers went just west of Samos to the town called Crotone. This town was located in the country of Italy. After landing there, he set up a commune with his followers. He classified people into 3 groups, and those who were interested in money, those who were interested in fame, and those who were thinkers. And he and his followers called themselves the thinkers. Pythagoreans believed in reincarnation and that beings had mystical powers. They were told not to share knowledge with the outside world that went against their beliefs. For example, irrational numbers. They didn't want anybody outside of their group to know about irrational numbers, and the people in his group were not allowed to tell anybody about irrational numbers. One of his followers told somebody from the outside world about irrational numbers, and Pythagoras had him killed. If you get over the fact that Pythagoras was a bit odd, you start to think that he's pretty smart. He thought that the cosmos was like a big orchestra and the planets were like its instrument. The music that it produced only the gods could hear. But what he's best known for is the Pythagorean Theorem. A squared plus b squared equals c squared. What's funny about that is Pythagoras was born in 582 BCE, and the Pythagorean theorem was probably used 2,000 years prior to that. It would have been impossible for the Egyptians to build the pyramids without the Pythagorean theorem. There's no question that it was being used at that time. But there is no written record that the Pythagorean theorem was used before 582 BCE when Pythagoras was born. He was the first one to write it down, and therefore he got all the credit. Let's take a look at the pyramid and look at this face. Let's say we're trying to design a pyramid, and from the base of the pyramid to the top is 3 meters. That 3 meters represents A in our equation, and we're going to substitute it with A. Now let's say that we want the base of our pyramid to be 8 meters. In order to use the Pythagorean theorem, our triangle would have to be at a 90-degree angle. So let's say that this face has two triangles, and they're both 90 degrees each. The entire length of the base is 8 meters, but the base of each of the smaller triangles is 4 meters. That's represented by the letter B in our equation. Our equation becomes 3 squared plus 4 squared equals c squared. Now there's one note about the Pythagorean theorem. C is always opposite the 90-degree angle, and it's called the hypotenuse. So now let's go back to our equation. We know that 3 squared equals 9, and 4 squared equals 16. 9 plus 16 is 25. And to figure out C, you have to see what number times itself equals 25. 5 times 5 is 25, so therefore C equals 5. So the hypotenuse of this triangle is 5 meters. Egyptian pyramids have 4 faces, and the height of these faces in this example is 3 meters. If it has 4 faces, then it has 4 bases, and the length of these 4 bases is 8 meters. We have to use the Pythagorean theorem to figure out the hypotenuse of the pyramid on each side. In this example, it was calculated to be 5 meters on each side. One last thing. Since the time of Thales, there have been all sorts of ideas about the shape of the Earth. Scientists come up with all sorts of crazy ideas. They thought the Earth was shaped like a pancake. They thought that it was shaped like a cylinder with round edges. But it wasn't until the time of Pythagoras in 582 BCE that they think that it was shaped like a sphere. He was the first one to come up with that idea, but in 2017, guess what? We think it's shaped like a pear. So that's the end of my video. I hope you enjoyed it, and please subscribe if you haven't. Peace.